Hey everybody, Mr. Troy here. I got a video for you on the parent functions of the sine and the cosine graphs. Get ready for some fun because it's time for math with Mr. Troy. Okay, so we're going to start with the sine parent function, which takes as its input an angle. We're always going to use radians for that angle. And what it gives as an output is the ratio of the sine. So, for example, the sine of pi over 6 is 1/2, would have the ordered pair pi over 6 comma 1/2. Whenever you're setting up a graph, you got to think IV, you got to think DV, you got to think what are my intervals. So since I am plugging in angles, I'm going to set up my graph to go on the independent variable from, let's say, negative pi to like 4 pi, just to see what it looks like. And for the y value, to see what that would look like, let's think about what the y values would be. The y values would be outputs of the sine. So I'm going to look at a unit circle real quick, and I'm going to think about what's the biggest thing the sine can be, what's the smallest thing. This can get a little confusing because the sine is the y coordinate on the unit circle, but it's also the y coordinate on our graph. So the sine can go anywhere from -1 down here at 3 pi over 2 to +1 at pi over 2. Okay, so that's what we're going to think for our axes. Okay, so I labeled that. I also marked in between on the horizontal axis for where the pi over 4s would be. We'll see why in a second. All right, here's your daily reminder. If you don't know the unit circle, you must learn the unit circle. Okay, cool. So I'm going to pick an angle, and I'm going to find its sine. I'm going to start with 0 radians, and its sine there is going to be 0 because the y-coordinate is 0. So I'm going to have the point 0, 0. Now, if I go to pi over 4, the y-coordinate is going to be root 2 over 2. Root 2 over 2 is about 1.41 over 2. So this is about 0.707. Okay, I'm going to mark that on my graph. Okay, next up is pi over 2. Now, pi over 2 is a right angle. So if you think about a right angle on the unit circle, look like this. A right angle on the unit circle would have a y-coordinate of 1 because it would be the coordinate 0.01 on the unit circle. So we would be right here. Okay. Our next would be 3 pi over 4, which has the same reference angle as pi over 4. Since they're both above the y-axis, they're going to have the same y-coordinate. So we're going to have the same output there. It's going to be root 2 over 2. On a graph, that's going to look like this. When we reach pi on the unit circle, that's going to be back to a y-coordinate of 0. So on our y-axis of our graph, we're going to be at 0. So we see this symmetry as we go up our graph. I'm going to do my best here to make a smooth curve. A little bit off there. And that's because of the symmetry here. These 2 points match each other, and these 2 points match each other. Okay, so next up is 5 pi over 4, which on the unit circle is this. It's from the half a right angle family, or the 45-degree family, if you're not comfortable using radians yet. That is going to have an output of negative root 2 over 2. So on our graph, I'll show you where that goes. So we're noticing this repetition, this repeating, and not only that, the symmetry is going to repeat as well. So 3 pi over 2 would have a sine of -1, and then we would be back to negative root 2 over 2, and then back to 0. So the way that I like to think about it for the sine is that we start out on the top half of the unit circle between 0 and pi, and then we're on the bottom half of the unit circle between pi and 2 pi. But the thing is, the unit circle just keeps going around and around and around. So it repeats. So if I need to find this value over here, it would be negative root 2 over 2, -1, negative root 2 over 2, 0, like that. And the same thing here. Just past 2 pi would be root 2 over 2, then 1, then root 2 over 2, then 0. So it just goes on like this over and over and over again, to negative root 2 over 2 to -1, negative root 2 over 2, 0. So this is what our sine parent function looks like. Here's what you need to remember. Its range is from -1 to +1, and it goes through the origin. Cool, right? Now, undoubtedly, you've seen this graph before, because anytime a movie or TV show wants to show that someone's a scientist, they have to put some sort of oscillating wave behind them. Mine's not perfect. It's a little too pointy. It needs to be a little bit more round. We'll see that in just a second. All right, so I'm going to graph the cosine on top of this sine, so I just copied my sine graph over. The thing that makes the cosine more difficult is that the cosine is the x-coordinate on the unit circle. So your input is an angle, and your output, your y value for your function graph, is the x value on the unit circle. And our first x value on the unit circle is going to be 1. Our first point on the unit circle at an angle of 0, our output is going to be 1. So the cosine is going to start at 1. The next x value will be root 2 over 2. It's probably going to be important for you later on that root 2 over 2 is the same for both of those, because root 2 over 2 appears in both the x-coordinate and the y-coordinate. Then for the cosine, at pi over 2, our x-coordinate is going to be 0. So what you see here is that this is the same shape as the sine graph, except that it's shifted to the left by pi over 2, or 90 degrees. Okay? So that graph, all told, is going to look like this. Movie magic? So the sine and the cosine have all of the same output values. They just don't occur at the same place. Okay? Those are our two parent functions. Okay, so I've updated our slide to now say the sine and cosine parent functions. We've got sine in purple, we've got cosine in blue. Now, we can check this against some things we know. For example, what is the sine of pi over 6? If you're still struggling with radians, pi over 6 is 30 degrees. The sine there is 1/2. So that would correspond to a value like that. Okay, so it still matches up, and it helps us understand the curvature of the graph a little bit better. Okay, so here's a slightly prettier version, a Desmos version of the sine and the cosine. And I want to point out what makes this important. Okay? The place where we're going with this is to solve equations like, when does the sine of theta equal 1/2? Well, what's important to know about that is that there are an infinite number of places where it happens. Sure, it happens here and here, but wouldn't it also happen here? If I say, where does the cosine equal negative 0.25. That would happen here, and here, and here. And the reason for this is because the sine and the cosine repeat forever. Okay? Functions that repeat after a set amount of time are called periodic functions. And trig functions are examples of periodic functions. These show up in physics class and even in engineering class and things like that. So they're super useful. We've got here an example, a square wave, a sine wave, and then some sawtooth waves. These are sort of things that would pop up in different places. Okay, since trig functions repeat indefinitely, we say what all of their solutions are using a general solution. So, if I asked you, hey, when is the sine of theta going to equal 0.1? You would say, well, it'll equal 0.1, here-ish and here-ish. But then again, here and here, and even over here, and so on and so forth forever into the future. So you would need to figure out one solution, another solution, and then you would need to figure out the general solution from there. So let's go to the calculator. The sine inverse of 0.1 equals... Oh, that's kind of cool and kind of confusing. The sine inverse of 0.1 equals 0.1. So let's go back and let's use the sine inverse of 0.2, shall we? Never mind, I just checked with my calculator and that wasn't any easier. Haha. Okay, so the sine inverse of 0.1 is 0.1. 0.1 is in radians. Okay. So what would this solution be? Well, it would be 0.1 plus 2 pi, because it would just be another lap around the unit circle. And then this solution would be 0.1 plus 4 pi. So the way that we would list all of those solutions is we would say 0.1 plus 2 pi times n, where n is an element of the integers. So when n is 0, it would be 0.1 plus 0. When n is 1, it would be 0.1 plus 2 pi. When n is 2, it would be 0.1 plus 4 pi. When n is negative 1, it would be 0.1 minus 2 pi, which would be, like over here. Okay, now for this other solution, what is that? Well, if this is 0.1, this would have to be pi minus 0.1. Does that make sense? Think about that for a second. So I'm going to change colors to make this a little bit easier to see. This point right here is pi minus 0.1. Okay? Which would make this point 2 pi away from it. So we've got pi minus 0.1, and we've got pi minus 0.1 plus 0.1. Or sorry, plus 2 pi rather. So that would be 3 pi minus 0.1. So our general solution for that one would be pi minus 0.1 plus 2 pi n by the same logic. Okay? Now, I'm going to give you a problem to think about, and it's going to be a lot simpler than that one. Okay, here's the problem for you to think about. Where is every single place where the cosine of theta equals root 2 over 2? Okay, think about that one. Okay, everybody, as you are leaving, I need you to remember a couple of things. First of all, we need to start thinking about turning in your phase 1 earnbacks, and you need to think about where your e-learning grade is and if it's where you want it to be. Okay? Hang in there. We're going to have fun solving trig equations all week. All right, see ya.